Today I'll be teaching y'all how to do composite functions. What is a composite function? A composite function is a function whose values are found from two given functions by applying one function to an independent variable and then applying the second function to the result, and whose domain consists of those values of the independent variable for which the result yielded by the first function lies in the domain of the second. Now, if that doesn't really make sense, or it's too much, to make it as basic as possible, it's a function whose values are given from two other functions. One of the functions is used as the x when being multiplied by the other. We'll start off with this example. Given that f of x equals 6x plus 7 and g of x equals 2x plus 3, find f of g times x. So this is a very basic problem, and your first step is to look at your functions f of x and g of x, and you see that g is being multiplied by f. So you look at your function f of x and you see 6x plus 7. Where the x is, that's where you'll plug in your g of x. So as you see in step 1, 6, and where the x is in your original function, 2x plus 3 plus 7. And the arrows will represent multiplying. So 6 times 2x, 6 times 3, and then you look to step 2, which equals 12x plus 18 plus 7. Now, back to basic algebra, you add the 18 plus 7, and you get your final answer, 12x plus 25 equals f of g times x. Our second example, given that f of x equals 2x plus 5 and g of x equals 4x plus 14, find g of f times x. So you look and you see 9x. So you go into your step 1, 9, where the x is. You'll put in your original f of x, 2x plus 5 plus 14. And you multiply your 9, and back to simple algebra, with step 2 being 18x plus 45 plus 14, which gives you to your final answer, 18x plus 59 equals g of f times x. And our next example is just a tad bit more complicated. Given that f of x equals 2x squared plus 5x plus 6 and g of x equals 4x plus 5, find f of g times x. So now that you have two x values, you're gonna plug in the x the same way. So 2 4x plus 5 squared plus 5 4x plus 5 in parentheses plus 14. So now, unlike the other examples, you're going to have to expand the groups of your square value and expand those out. And once you do that, you're going to go and proceed on to your next step, which is just like the original, and 2 with your expanded groups, 16x squared plus 40x plus 25 plus 4x plus 5 plus 14. And again, here's simple algebra from here on out. 3x squared plus 80x plus 50 plus 20x plus 25 plus 16. Your next step is just to combine like terms, and then that brings you to your step 5. 32x squared plus 100x plus 81 equals f of g times x. And our next example is given that f of x equals 12x squared plus 7x plus 3 and g of x equals 4x plus 2. Find f of g of x. So again, like our previous problem, you're going to set it up 12 4x plus 2 squared, because you have the x value squared, plus 7 4x plus 2, which is because that's our g value, plus 3. Again, you have to expand the groups. 4x plus 2 times 4x plus 2 bring you to 16x squared plus 16x plus 4. From then on, step 3, you just multiply the 16x squared plus 16x plus 4 by 12, and then you add that to 7 times 4x plus 2 plus 3. That'll bring you to 192x squared plus 192x plus 48 plus 28x plus 14 plus 3. And again, simple algebra, you break that down into 192x squared plus 220x plus 65 equals f of g multiplied by x. Now here's as complicated as composite functions will get. Our problem reads, given that f of x equals 4x squared plus 12x plus 17 and g of x equals 2x plus 10, find f of g times 2. So just like our previous problems, you're going to expand the groups and find what it equals to x first. So step 1 is to write out your problem. 4 times 2x plus 10 squared plus 7 times 2x plus 10 in parentheses plus 3. You'll expand your groups of 2x plus 10, which will bring you to 4x squared plus 40x plus 100. Then you multiply 4 times 4x squared plus 40x plus 100, because that's your value of that's your squared value, plus 7 times 2x plus 10 plus 3, which brings you to your fourth step, which is again just breaking down and adding like terms together, which brings you to step 5, 16x squared plus 104x plus 537, which equals f of g of x. So now, when you look back to your original problem, you have to find f of g of 2. So where your x is in step 5 of 16x squared, 184x plus 537, where your x's are, you will plug in 2. In step 6, you're going to rewrite step 5, except leave off the f of g of x. And then where your x is, you're going to plug in a 2 and square those values for your 16 times 2 squared, and then multiply 184 times 2, which will bring you to 64 times 368 plus 527, and which will bring you to your final answer of f of g of 2 equals 969. And for our last example, it's a challenge problem. Given that f of x equals 12x squared plus 7x plus 3 and g of x equals 4x plus 2, find f of g of 2. So just like all of our previous problems, you'll set it up, you'll expand the groups, which will bring you 16x squared plus 16x plus 4. Multiply those out, and you'll get 192x squared plus 192x plus 48 plus 28x plus 14 plus 3. You combine like terms. 192x squared plus 220x plus 65 equals f of g of x. And now, again, you're going to plug in 2, because that's what we're finding, f of g of 2, where all of your x's are. So 192 times 2 squared plus 220 times 2 plus 65. And then you'll combine your answers, because adding, you're going to add all your answers together. And f of g of 2 equals 1,270. Thank you for watching.